Welcome to This Explainer. If you're joining us today, you already know the deal. The world of environmental engineering and industrial compliance, it's not just about reading textbooks or looking at ideal, perfectly drawn scenarios on a whiteboard, right? It is a demanding, incredibly vital field. Today, we're taking a deep, focused look at a comprehensive curriculum from QSTI Prep Academy. We're going to explore how their training completely transforms theoretical knowledge into the hard, practical field skills that industries literally cannot function without right now. So get ready, because we are going to break down exactly what it takes to master environmental monitoring from the absolute ground up.
Okay, let's dive into this. Do you want practical knowledge about stack emission testing? It's a simple question, right? But it really gets to the heart of why we're here. Are you looking for real-world EPA method and analyzer training, or are you just kind of settling for high-level concepts? The materials we're reviewing today are built entirely around one core premise. True expertise in environmental monitoring only happens when practical field experience actually meets professional environmental training.
Here's our roadmap. First, we'll look at the gap between theory and practice. Then, mastering core EPA methods, followed by stack and fugitive emissions. After that, we'll tackle equipment and analyzer calibration and wrap the whole thing up with your future in compliance.
Section 1. The gap between theory and practice.
So the core issue in the industry right now is this massive gap in knowledge. Most online videos and resources out there, they only explain the theory. They tell you what should happen in a perfect world. But what industries actually need to maintain compliance are practical field procedures. They need professionals who have real equipment handling skills and can execute EPA methods step by step. The gap between just knowing what a smokestack is and actually setting up the equipment to monitor its emissions accurately, it is massive. To bridge that gap, you need some very specific skills. The QSTI curriculum hits on 4 critical areas. First up, practical calculations. You aren't just plugging numbers into a textbook formula. You're out there calculating real-time velocities and moisture levels on site, constantly adjusting to changing atmospheric variables. Second, QA/QC procedures, quality assurance, and quality control. Look, if you can't prove your data is absolutely rock solid and verified, it's completely useless for legal compliance. Third, learning through industrial case studies. These really strip away those perfect theoretical scenarios and show you the unpredictable curveballs of how things actually play out in real operating facilities. And finally, troubleshooting techniques. When you're out in the field on a massive site and your gas analyzer suddenly drops its signal, a textbook isn't going to save you. You need practical troubleshooting to get back online, fast. True expertise comes from mastering these exact, real-world procedures.
Section 2. Mastering core EPA methods. Now, what's really interesting about this is the sheer precision of this core EPA training. We're not just talking about general air testing here. We're talking about the exact legally required regulatory procedures. QSTI Prep Academy focuses heavily on these core methods, and understanding why they matter is a real game changer. For instance, methods 1 and 2 are your absolute foundation, dealing with sample and velocity traverses to map out the airflow inside massive industrial stacks, making sure you sample from the correct points. Then you have method 5, which is absolutely critical for capturing particulate emissions, the actual physical dust and soot that can harm surrounding communities. Method 9 trains your eye for visual opacity, so you can officially certify exactly how much light a plume of smoke is blocking. And Method 21, that's your standard for hunting down volatile organic compound leaks hidden inside thousands of complex pipeline connections. Mastering these specific methods step by step, along with the intensely rigorous EPA calculations and reporting, is absolutely crucial for verifying industrial compliance. Without this strict execution, a facility literally cannot prove to regulators that they're operating safely. Section 3. Stack and fugitive emissions.
As an HSE professional, you're operating in 2 entirely distinct environments, and you really have to master both. First, there's stack emission testing. This is your direct output, what's actually coming out of the chimney. It requires highly technical, almost surgical procedures like isokinetic sampling, where you have to extract a sample from the stack at the exact same velocity the gas is moving, otherwise you totally skew the results. It involves assembling complex sampling train setups, running real-time velocity and moisture calculations, and conducting highly targeted particulate sampling. Now, contrast that entirely with fugitive emission monitoring. These are the unintended leaks, the invisible, often toxic gases escaping quietly from microscopic gaps in valves, pumps, and flanges. Here, the focus shifts to LDAR procedures. That stands for leak detection and repair. You're out there in the maze of a refinery, tracking VOC leaks using highly sensitive hardware like PID and FID analyzers. These are two completely different monitoring challenges, but both are entirely necessary to secure a facility's environmental footprint.
Section 4. Equipment and Analyzer Calibration.
Let's be real. A gas analyzer is only as good as its calibration, period. The training emphasizes a highly structured, unyielding approach to ensuring equipment accuracy. Step 1. You absolutely must perform strict zero and span checks. This means feeding the analyzer a gas with zero concentration and then a gas with a known high concentration. This establishes your baseline and your exact measurement range, proving the machine is actually responding correctly. Step 2 is conducting regular instrument maintenance. Field conditions are incredibly harsh out there. You're dealing with extreme dust, corrosive gases, heat, moisture. All of that degrades sensitive equipment, and you have to know how to maintain, clean, and recalibrate it right there on site. And step 3, master data interpretation. Once the machine is calibrated and gives you a parts per million reading, what does that actually mean for the facility's compliance limits? Understanding this whole logical flow is how a gas analyzer is rigorously calibrated to yield legally defensible results that will actually hold up to regulatory scrutiny.
But of course, industrial compliance doesn't just magically stop at gas and particulates inside a facility. A well-rounded HSE professional has to be proficient in measuring other critical environmental impacts that reach way beyond the fence line. True professionals also handle noise monitoring to make sure industrial operations aren't violating acoustic thresholds. We mentioned opacity monitoring earlier, confirming exactly how much light is blocked by a smoke plume. And then there's ambient air monitoring, which shifts the focus outward to see exactly how the surrounding community's air quality is being affected by the plant. Wrapping all of these disciplines together with overarching environmental compliance procedures, that is exactly what transforms a standard technician into a complete, highly valuable asset in the field.
Section 5. Your future in compliance.
So the really crucial point here is the number 10. The foundation of the QSTI Prep Academy training isn't derived from some textbook printed last year or academic theories that have never even seen a smokestack. It's backed by more than 10 years of real industrial field experience in environmental services and monitoring operations. The procedures, the troubleshooting tactics, the unpredictable case studies, they are all battle-tested over a decade of actual on-the-ground work in multiple, highly complex industrial projects. And honestly, that is the exact kind of professional guidance that bridges the gap and dramatically accelerates a career.
This brings us to a really powerful reality of the modern industrial world. To quote the source directly, environmental monitoring is becoming more important every day. Industries require trained professionals who understand environmental compliance. And it's so true. Regulatory standards are tightening globally, and there is absolutely no reversing that trend. The industry demand for specialized, practically trained environmental engineers, technicians, and HSE professionals is urgent, and it's growing exponentially. Gaining this hands-on, deeply practical industry knowledge directly supports and really future-proofs your career against a rapidly changing world.
We'll end on this powerful mantra: learn, monitor, protect. It perfectly summarizes the journey we've discussed today. You learn the practical field procedures, you accurately monitor the industrial outputs using rigorous EPA methods and finely calibrated analyzers, and ultimately, you protect our environment and ensure industrial safety. So I'll leave you with this provocative thought to ponder. As industries expand and environmental regulations become even stricter, how will you bridge the gap between theoretical knowledge and the practical field skills needed to be the one protecting our air quality tomorrow? Think about it. Thanks for joining me on this explainer, and keep learning.